Today's video is on thermal expansion. In particular, we're going to be covering linear expansion. So let's get the title on. Expansion. So linear expansion. So what is thermal expansion? So if I was to give you an example, thermal expansion is, so if we had a metal rod, and we added heat to it, it would expand. So if I give you a further example, actually. So if this is an atom, and this is another atom, we know that heat is just energy between the particles or atoms in a system. So if I was to say them are two atoms, so when we add heat, the more energy it has, the more hotter it gets, so the high temperature. So let me just state that again, just to be more clear. So if I add heat to a system, the temperature goes up because there's more energy. So if I think of these atoms connected by a spring, so they're actually always vibrating. So they're vibrating, like I said, and when you add heat, there's more energy, so it vibrates more, so the temperature goes up. So if this was this is a piece of my rod, to say, so these two atoms are in my rod, and right now there's no temperature, so it's at 0. So if I was to add some heat to it and draw the atoms again, we can see adding heat to it, there's a greater distance between them because there's more energy in the system, so there's a greater distance between the atoms, so the amplitude has gone up and the energy has gone up. So like I said, so the first one, if I was to draw the rod, that's the rod, it's a normal size, but then when we heat it up, it increases in size. So it all depends on the temperature. So that would be the initial, that would be final, and that would have a initial temperature, and that would have final temperature. So we can write an equation to represent all this, and the equation is, let me choose a different color, bear with me. So the equation is, so change in length is equal to a constant, is alpha, I'll get to that in a minute, times the initial length times the change in temperature. So let me write that again and go through that. So the first part is change in length, so we can rewrite that as that is equal to final minus initial. So if we write that again, our equation, so final minus initial equals alpha. So this alpha is just a constant, and it's called the coefficient of expansion. So this is the number that would be given in the exam or test. Each, like, different materials have different constants. So the units for that is Kelvin to the -1, or it can be Celsius degrees to the -1, because they're both equivalent. We covered that in an earlier video. So that's alpha is followed by the initial length, delta T, and that's delta T is just final temperature minus initial temperature. So that's what delta T is. So in exam we might be asked to find the final length. So if this is the initial length, then we're asked to find the final length. So we have to rearrange the equation, really, don't we? So I'll just do that quickly in the next slide. So if that's, let me just rewrite the equation again. Oh my bad, that's alpha. That's a bad alpha, but let me just fix that up. So alpha L naught. So okay, we want final length. So we could just take this initial to the sides. This is just simple algebra, really. So it'll be, if we take this to the other side, it'll be L naught plus alpha L naught delta t. And there we have it. We have the final length, but we could clean that up more. L equals, so there's a common factor here of L naught, common factor here of L naught. So if I take that out, one minus alpha delta t. So that's the final equation we have there. So right there.